Okay, so today we are going to be working with some equations some more, and we're going to actually be graphing them, drawing a picture of them. But I want to set this up with why we're doing this. Okay, so as I look at this equation, y equals 2x minus 1, I see something different. This is the first time we've seen an equation with both an x and a y. Now, typically what we would have is we would see 2x minus 1 equals 7. Or something like that. And then we could solve that, right? Because we would just add the 1 over, and we'd say 2x equals 8, and then divide by 2, and you'd be able to tell me x equals 4. And that's no problem. But this time we have a y and an x. And actually what that's going to mean is there is an infinite number of solutions to this. When it was 2x minus 1 equals 7, there was only one solution, and that answer was 4. But since there's more than one variable, there's actually going to be an infinite number of solutions to this. So what is that going to mean? Well, first of all, let's do this. I'm gonna make a table, and an XY table. And let's just find out what some of those solutions are. So we're going to start with x is negative 2, then we're going to go negative 1, 0, 1, and 2. All right, and let's see what happens. So if I put negative 2 into this equation back over here for x, I would have 2 times negative 2 minus 1. And what's that going to be? 2 times negative 2 is negative 4, minus 1 is going to be negative 5. So that's an answer to our equation. If x is negative 2, then y is negative 5. But like I said, there's lots of different answers for this. What if we put negative 1 in there for x? So I'd have 2 times negative 1 minus 1. 2 times negative 1 is going to be negative 2, minus 1 is going to be negative 3. Okay? And let's continue to do the same thing for 0, 1, and 2. If I put 0 in for x, 2 times 0 is 0, minus 1 is going to be negative 1. And if I put 1 in for x, 2 times 1 is 1, minus 1 is positive 1. If I put 2 in, 2 times 2 is 4, minus 1 is 3. Okay, so I found 5 different solutions to this, all right? And honestly, I could keep going. I could keep going to 3 and 4 and 5. I could do 5.1, 5.2. 5.21, 5.22, 5.23. There's actually an infinite number of x's that I could put in there. And I don't know. Raise your hand if you are not in favor or if you're against finding a million different solutions. I'm against that. Let's not do that. Let's instead put this on a graph and see what happens. So I'm going to graph our first solution, negative 2, negative 5. So negative 2, negative 5 is 1, 2, 3, yeah. Negative 2, negative 5 is going to be right there. And then my next solution was negative 1, negative 3. That's going to be that point right there. Next solution is going to be the point 0, negative 1. The next solution was 1, 1. The next solution was 2, 3. And if you see what's happening here, we could continue to do this forever. And actually, if we would do that, we would just keep adding dots kind of in between there, adding solutions to those. All those solutions are going to fall right there. And if you see what this is, if we would add millions and millions and billions and infinitely many dots on here, what you would see is that it would form a straight line, just like that. Okay? Now, this method that we used, making a table, I want you to remember this. You can use an XY table to graph anything. Okay? Any equation that we give you, you can use an XY table to graph that. Now, some are going to be easy, some are going to be hard, but you can always use an XY table to graph it, because remember, a graph is just a picture of every single solution. Okay, like I don't want to say all of these solutions every time and the millions of other solutions. I just want to draw a graph of it. Now, we're not actually going to have to do this XY table every time, because there's another way. This equation is written in what's called slope-intercept form. Okay, slope-intercept form. The number in front of your x is your slope. That means how steep your line is. Okay, it's how fast something is changing, or in this case, how steep a line is. And so the number in front of the x is the slope. The number by itself is the y-intercept, where it crosses the y-axis. So watch what we can do. We're going to start with the y-intercept. The y-intercept is -1, so we're going to go down to -1 on the y-axis. And then the slope is 2, and that means we're going to go, for every 1 we go over, we're going to go up 2. So we're going to go up 2 and over 1. From our y-intercept, go up 2 over 1. And then we can do that again, up 2 over 1, up 2 over 1. And you see we have the exact same line. So that's going to be the method we use, okay? Let's buzz through some of these real quick. Okay, the first one right here. Y equals 1/2 x plus 3. Well, this number out here by itself, the plus 3, that's our y-intercept, so that's where we're going to start by going up 3 on the y-axis. Now, our slope is 1/2, and actually, fractions are super easy to understand when it comes to slope, because if I asked you to read this, you could say it's 1/2, or you could say it's 1 over 2, right? So slope tells you how much you're going up, and I'm going up, and you just read it, 1 over 2. So from this dot, I'm going to go up 1 over 2. So just read your slope. 1/2 is just 1 over 2, so you're going to go up 1 over 2. Let's do it again. Up 1 over 2, up 1 over 2, up 1 over 2. And I can do the same thing coming back. Down 1, back 2, down 1, back 2. And this is going to be our first line. Okay, let's look at the next one. Y equals 2/3 x minus 5. Well, the minus 5 is our y-intercept, so we're going to go down 5 on the y-axis. And then our slope is 2/3, or our slope is 2 over 3. So we're going to go up 2 over 3. Up 2 over 3, up 2 over 3, up 2 over 3. And this is our line. Okay, next one, y equals -1/4 x plus 7. Okay, now this one's going to be a little bit different. There's something tricky in here, but the y-intercept is definitely still 7. So I'm going to go up 7, 2, 3, 4, 5, 6, 7. And then my slope is -1/4, -1 over 4. So when it's positive, we were going up. But since this is a negative slope, now we're going to go down. So we're going to go down 1 over 4. And we always go over to the right, just like we read. Okay, so we're going to go down 1 over 4, down 1 over 4. And this is going to give us a pretty nice start for the graph. All right, let me do this last one in red so that we can see it a little bit clearer. So y equals 2x minus 1. So our y-intercept is -1, so we're going to go down 1. Now, let's look at this. Slope is like the only time ever where fractions are easier. So our slope is 2, because that's the number in front of the x. Our slope is 2, but what exactly does that mean? Let's think about it as a fraction. If I change 2 into a fraction, it would just be 2 over 1. Okay, so 2 over 1 as a fraction means I'm going to go up 2 over 1. So I've got my y-intercept at -1, and then my slope is 2 over 1, so I go up 2 over 1, up 2 over 1, up 2 over 1, and that's my line. Let's do some more of these. Next one, y equals -3x minus 1. So my y-intercept is -1, so I'm going to start down 1. My slope is -3. Thinking about that as a fraction, that's going to be down 3 over 1. Down 3 over 1. Down 3 over 1. So that's where it's going to be. So when I'm saying down 3 over 1, that's really what I'm thinking. Down 3 over 1. And this, whoops. This is going to be our line. And I got messy. Sorry about that, but it happens. Nobody's perfect, right? I'm going to do the next one in blue. y equals negative 2/3 x minus 5. So my y-intercept is negative 5. 1, 2, 3, 4, 5, going to negative 5 on the y-axis. Then my slope is down 2 over 3, negative 2/3, down 2 over 3, down 2 over 3. And this is my line, more or less. Let's do the next one in orange. Negative 2x plus 7. So my y-intercept is positive 7. 1, 2, 3, 4, 5, 6, 7. My slope, if I think about that as a fraction, is negative 2 over 1, down 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 2 over 1. That should be enough for us to get a pretty good line here. And that's our line. Okay, last one, let's go green. Y equals 5x minus 1. So negative 1 is my y-intercept, and my slope is 5, or 5 over 1, so I'm going to go up 5 over 1, up 5 over 1. And this is my line. Okay, so remember, a graph is just a picture of every single solution, right? Because we don't want to write out a million different or an infinite number of solutions. We don't want to write all those out. So instead of that, let's just draw a picture of every single point. We can graph anything by making an XY table and subbing those numbers in. If you don't remember that, just go back and watch the beginning of the video. But with slope-intercept form like this, all you have to do is look at that number by itself. That's your y-intercept, how far up or down you go. And then look at the slope. If it's positive, you're going to go up. If it's negative, you're going to go down. All right? I know you got this. Good luck.